All right, section 10.7, we're talking about inscribed and circumscribed polygons. Let's see what we got. All right, so first of all, some vocabulary. If you have a triangle and it is inscribed in a circle, what that means is that all of the vertices of that triangle are going to be on the circle. So they're not going to be outside, they're not going to be inside, but they're actually on the circle. And then the center of that circle is considered the circumcenter of the triangle. So you guys remember doing this in constructions, right? Where you were given a triangle and you had to figure out where the circumcenter was by doing some constructions, and then you were able to construct the circle that was going outside of the triangle. Well, we could talk about that circle as being circumscribed about the triangle, or you can say that the triangle is inscribed inside the circle. It's all a matter of like which one relates to the other and what order, right? Because we could also talk about a situation like this, where you can say that this polygon, ABCDE, is circumscribed about the circle, or we could have said the circle is inscribed inside the polygon. So there's a distinction there. It's just a matter of which way you're going to relate it. So in this case, when the polygon is circumscribed about the circle, each of these points right here are points of tangency. So all of the segments that make up the polygon are going to be tangent to the circle. Okay? P is considered the incenter of the polygon. All right, so there's some vocabulary for you. You just need to know this because sometimes they'll describe a diagram using these words, the inscribe and circumscribe, so you need to know what they're talking about. Okay, here's a theorem for you. It says that if a quadrilateral is inscribed in a circle, then its opposite angles are supplementary. This is going to be really nice because now we don't have to use our formulas with inscribed angles that we learned before. If we know we have a quadrilateral, and that just means four sides, so it's only for the quadrilaterals, nothing else. If we know a quadrilateral is inscribed in a circle, that means that A, B, C, and D are all on the circle, then opposite angles are always going to be supplementary. So that tells us that angle C plus angle A is going to be 180 degrees. And likewise, angle B plus angle D is going to be 180 degrees. So if they give you angle B, it's really easy to figure out angle D without having to figure out arcs or anything. You can just subtract it from 180. All right, and then the last theorem that we have for this section, Theorem 94, talks about if you try to inscribe a parallelogram inside of a circle, it's always going to end up being a rectangle. And that's a theorem. There's no way that you can actually get a parallelogram inscribed in the circle and not make it a rectangle. I dare you to try to do it. It's impossible. Because in order for it to be inscribed, remember that all four vertices have to be on the circle. And what usually happens is people say, oh, okay, well, I can do this, I'll do this right here, and then I'll do this one, and then they're like, oh, but I can make a parallelogram and do that. Oops. Okay, that was really poorly drawn, but you get it, how this point right here, you got this point, you got this point, and you got this point. Those are all on the circle, but this one right here is not. And so the only way to get this one over on the circle is to straighten everything out and make it a rectangle. So when they give you, maybe they just say parallelogram ABCD is inscribed in a circle, you need to know that they're actually talking about a rectangle. Because if it's a rectangle, then you've got right angles, you can draw the diagonal, get right triangles, do all that fun stuff that we learned from chapter 9. All right? Okay, that was a pretty quick section. We like that. Toodaloo.